All right, on this table, this is the original function. This data is for the original function. If you differentiate it twice, means that we could actually look at charts about the other if we had formulas. Does that make sense? Which means it would have maxes, mins, or inflection points probably in it. Now, what they're asking us to do is talk about the first derivative. Is it positive or negative? And then, after you figure out if it's positive or negative, look if it's increasing or decreasing.
I forwarded you an email.
Uh-huh.
And we won't, you're fine. I just feel like there's a lot.
So, it would be very important to know if it's positive or negative first. Would that be? Now, first derivatives, or negative or positive, tells us what? Like when it's below the x-axis and above the x-axis on a graph, but... Okay. Okay, so that tells us increasing and decreasing, right? If your values of your first or second derivative are, tell us stuff. The value of the first derivative tells us if it's increasing or decreasing. So, positive or negative, now I'm not talking about this word increasing, decreasing. I'm going to talk about that in a minute because that's where we got confused yesterday. This word right here is all about what this graph should show on a derivative. So let's think this through. If we took the time to plot all right, something like that. It's not straight. That's not what I want to talk about. No, it's not straight. No, it's not straight. I'm just plotting. Can you see they're going downhill? Okay. Everybody sees they're going downhill, right? Does that tell me that my graph would have a negative for every one of my derivative parts? Yeah. Because what's the slant of this line? Whether it's straight or not, it's all decreasing, right? And what does decreasing in the first derivative means is this word negative tells me that my graph should be going downhill. Okay? Now, I would have graphed that better, but I'm in a hurry. Now, how much did it go down? 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 Now, let's talk about that. So when I think of a second derivative graph, what I'm saying is when I go over 1, okay, how much up it is the value of the derivative, right? So let me graph these values. Now I'll graph these a little better. All right, so if I go over 1, I go up 5 approximately. Go over 2, go up 4 approximately. Go over 3, up or 4. That's just approximate. This is just talking about what's the space in between. I might have done that wrong. Let me try that again. That's not what I want. Let me think that through again. It's what I want, but it's not what I want. Let me try that again. If I go over 1 and up 9, 9 would be way up here, right? And if I go up 4 on that 2, the space between here is great. Would everybody agree with that? All right. But when I go over to 0, the space each time, what do you think's happening to the space between these numbers each time? It's getting smaller. Okay. So that means that if I find the slope between those places, if I had the slope at each of those places, we should be able to tell something about the slope. We've got to figure out if the graph of the derivative is increasing or decreasing, which tells me concavity. Okay? This word over here is all about the concavity, just like yesterday. Is the derivative graph going uphill or downhill? Now, I was going to try to plot it with something, but my plot's not working really well. So I went back to the original data. The space between here is getting smaller. Everybody agree? Now, if I was working on my problems with the derivative values, all of these derivative values would be negative because it's decreasing the whole time on my original graph. Everybody understands my derivative's negative, right? So let's think of it like this. It had the most space right here. It's going to get a little less space between them each time. Because we're talking about the negative value, right? These are all negative. See, that's what I did wrong the first time. When I go over 1, it's down 5. When I go over 1, it's down 4. When I go over 1, it's down 3, because they're all negatives, because it's going down by that amount, right? What's happening to my derivative graph? It's increasing because it's getting closer to not being negative anymore. Does that make sense? Right, which is what the increasing means. So therefore, the correct answer to this was B.
We can tell that by amount of spaces in between.
You can kind of tell that by the amount of space it's in between, as long as these are going by ones. Now, if these weren't going by ones, I might have to divide it by what the difference is. But because these were all negative, the space between them got less each time, and making my derivative graph increase, which shows me concavity to be up. Okay. Let's look at the next question. 88 talks about an Ln function and a fifth power quintic function. And they want to talk about the two functions' tangent line. It says the tangent line of the graph f at x equals 2 is parallel to the tangent line of g at x equals some unknown value a, where a is a positive constant, which is good to know because we wouldn't want to pick the negative one in case there's more than one answer. And what would the value of a be? So, let's talk about first, what all can we do about tangent lines? Well, first of all, when we look at tangent lines, we're talking about derivatives, because you got to have a slope, right? For them to be parallel, what do the slopes have to be? There you go. So first, I have to calculate the slope, so I've got to come up with a derivative. So I put that on bottom, and I put the derivative on top, and there's my derivative, and I plug 2 in. 2 times 2, 2 squared plus 1 comes out 4 over 5. There's my slope. Everybody with me so far? Now, I want to know how can the other line have that same slope so it'll be parallel. So I take the derivative of the other line. 5x to the 4th plus 3x squared. And you set it equal to 4/5, and you solve it on the solver on the calculator, and out comes the answer. Because the derivatives have to be equal to each other. And I just have to figure out what value of x on the other one for that a would make it equal, because it won't be the same value on each one. And so that's kind of how you go about that one. I think the correct answer to that one was C, if anybody wants to play around with checking their answers and trying questions again. But that's how you go about that one. And it's not complicated because it's what we know about slope. We know parallel lines have equal slopes, so we just get the derivatives, evaluate one, and set it equal to the other one. All right, in number 89, you have another one of these things that looks like the second fundamental theorem of calculus. Would you agree? Okay. And then it talks about a lot of things in here, so let's go piece by piece. It's continuous function on real numbers. Well, that's important to know because it's not you can't integrate if it's not probably continuous. It gives me that second fundamental theorem of calculus thing over there, which is important because that tells me something about my problem. It tells me that if I take the derivative of this side, that the integration of this puts an x in, right? If I take the derivative of this side, then I have this. That the derivative inside the integration is equal to the derivative of this. Now that's important to know. What that notation means. That when you differentiate both sides, the integration symbol goes away. Does that make sense? Okay. Now, it also talks about average rate of change. And it tells us that the average rate of change is equal to 6. So, well, they basically made them all equal to 6, so at least we know that we're on the right track there. We just have to figure out which one of these statements is correct. Now, isn't average rate of change something that we typically talked about with integration when we put the, at least average was. Did we talk about average with that integration? We talked about rate of change with derivatives. So those two things being together kind of seems a little strange, doesn't it? But then again, we just took a derivative of an integration problem over here. So that might have something to do with it. Now, let's talk about what each one of these means. This means I'm integrating from 2 to 5, that interval, g of x. Okay? Is not what that over there says I'm integrating, by the way. This one says I'm going to take the two numbers on the end's derivative values and add it up and divide by 2. That sounds like an average. Doesn't you add two things together by 2 usually give you an average? And they're averaging the rates, so that kind of sounds right. This just says if you evaluate your derivative at 2, you'll get 6. Well, if you're talking about an average rate of change, do you think it's going to happen on the first number? Probably not. So that one definitely doesn't sound right at all. Would everybody agree? When we talked about average before, didn't we put 1 over something in front? I don't think it's that one, because we always put over 1 over something. Now in this class, have you ever seen us add two numbers together and divide by 2 to get anything? No, because the answer is A. The average value of f on that interval is 6 because of this notation. Because if you take the derivative of this side and you take the derivative of an integration problem, then you just end up with basically that. So since that is what you end up with, it makes sense that the average value of f is the answer that's 6 because the derivative is equal to f. So sometimes knowing something about notation is important. 90. In question number 90, is that the last one? Because if it's, okay, good, because I was afraid I'd left 2 off or something. Because sometimes there's 92. All right, they have 3 statements. Some of these might be true. So we got a 1 and 2, 2 and 3. All of them are only 3. So I guess we should figure out if 3 is right because there's 3 of them that have that. Does that make sense? F is differentiable on this unit, this value, if the limit of the function is equal to f of a. That means the whole would be colored in. That seems reasonable. All right, continuous on a if the limit is also equal. Then you know that's the limit, and then you know it's continuous, okay? And if it's continuous, it has to be differentiable, right? Okay. And the f is defined at a if the limit of that is f of a. No. It doesn't have to be defined because it could be a whole. And still the limit would be that. So that's where this problem's answer is just C, because it has to be continuous. It has to be differentiable. In both of those cases, the limit at that would be f of a, whether it's colored in or not colored in. The limit would be that. And that's where this defined at A thing might not match the limit. Remember those graphs where we had a graph with a hole in it and there was a dot up here colored in? All right. That's not continuous, right? But the limit still would be this number. Does that make sense? All right. That's what the defining part's talking about. For it to be defined at that number, this number has to be colored in. And it has to be colored in where the limit would be.
Can I tell you how I knew? Like, I got this right, but the reason why I got it right
Uh-huh.
is I was looking at them. I was like, it makes sense for it to be continuous. And I was like, and in order for it to be differentiable, it has to be continuous. So I was like,
Right.
that first one just doesn't seem.
And that first one is wrong because it doesn't have to be colored in to have that answer in that limit.
I just made an
Yeah.
educated guess.
Did you get it right?
Yep.
Good. Good. I'm glad your educated guess worked.
My educated guesses are all B's, so I didn't put B and I got this one right.
All right. No, that's not it. Hold on. Okay, here's the chart problem. So we have 4 questions to answer on this chart problem. This would be worth 9 points altogether, so we can talk about each question here and how many points it's worth. This chart shows the original values of f, the derivative value for the slopes. It also talks about the interval between them for the positive and negative, so we can talk about increasing and decreasing. It does it for g also the same way. So we're going to go through and look at each of these questions and talk about what part of this chart would you have to look at to know that information. So in part A, it says find the x-coordinate with each relative min of f on the interval from -2 to 3. Justify your answers. Now, we're not looking at G, we're looking at F. Does that make sense so far? Everybody okay with that? All right. Now, the second thing that's very important in this question is to focus on the derivative part of your problem. This is a combination chart. When you want to talk about means, look at the derivative part words. Negative, negative, positive. Which one of those words means mean? Negative to positive or negative to negative? Negative to positive, because that means it's decreasing and then it's increasing. So sometimes what you might want to do is go in here and fill in that increasing, decreasing word, because it might give you something to go on later. So when it goes decreasing to increasing, this is a min. So in that question, I would say x equals 1 is a critical point because the derivative changed from negative to positive, and therefore f has a minimum at x equals 1.
Oh, you're just telling us the sentence, aren't you?
Does that make sense? All right, I'll say it again. X equals 1 is only critical number because it didn't change over here from negative, negative, right? In which the f prime changes from negative to positive, and therefore the relative mean is x equals 1. That's two different sentences, by the way. I didn't run that all together. Now, that question is worth 1 point if you get all that thought process in there. That it's a critical number, that it changed from negative to positive, causing it to be a min. Does that make sense? A relative min. And if they use the word relative, you should use the word relative. If they don't use the word relative, then just say min. How do y'all feel about that kind of concept? Does that seem simple? Yeah, that could be a point you could get easily by just reading the chart and figuring that out. Now, some people like this chart separated because it bothers them that it's two functions together. So some people come in here and they draw themselves a big, huge line through here so they can focus on half of it at a time. All right, part B. Explain why there's a value C between negative 1 and 1 such that the derivative at C is equal to 0. So let's talk about that. Now, how can I tell y'all how to do that? We don't have a derivative to look at, right? For second derivatives. All we've got is this chart. Everybody agree with that? And we want to figure it out based on the values at 1 and negative 1 in the derivative. In the derivative, okay? Now, second derivatives are equal to 0 when the slope's equal to 0, right? And does the slope in this problem have to be equal to 0 when you subtract them? And for that to happen, the top has to be 0. So when I subtract those two numbers, the derivative values being 0 and negative 1, and 0 at 1, 0 minus 0 is 0, divided by 2 is still 0. And so that proves that has it. So you have to do a slope, a regular y2 minus y1 over x2 minus x1. But before you do all of that, there are things you have to make sure that are known. 1, you have to say it's differentiable and it's continuous. Why? I'm on part B, so just focus with me a minute. Why would it be important that this function is differentiable and continuous? Right, it has to be that. So let's talk about how would you show the work for this. Number 1, you would say f prime of x is continuous. I'm going to abbreviate that word. And differentiable. I'm going to abbreviate that word. On the interval from negative 1 to positive 1. Now you could even get more specific and say continuous on that interval and differentiable on the open interval. Now, do you remember some problems we used to do that? So we made those two separate steps. Remember some problems we used to do that? What was it called? Mean value theorem. So then in start 2, you'd fill this out. And say 0 minus 0 over 1 plus 1 is 0. That's worth 1 point to get all of that to come out to be 0 and have your information. And then you just make a sentence. Therefore, the mean value theorem, there's at least one value of C in the open interval that they gave me, that F double prime of C is 0. That's the sentence you would write. Mean value theorem, by the mean value theorem, there's at least one value of C for the interval from -1 to 1 on the open interval, such that this is equal to 0. So you can actually take the question that they ask you and just add a little information to the beginning of it by starting off about the mean value theorem. There's at least one value, and then the rest of it could be just what basically is there. Does that make sense? That's what the mean value theorem is all about. The mean value theorem is all about the fact that your slope, and actually this is an example of Rowley's theorem, but they don't use Rowley's theorem on the test. They just let everything be mean value because it's easier. Because sometimes they don't cancel out and make 0. Sometimes they actually give you an answer. But it has to be continuous, it has to be differentiable on the open interval, and it has to be the slope formula comes out to be whatever they say it does for the mean value to have at least one value of C to meet that criteria. That's worth an extra point to write the sentence. So this question's worth 2 points. You should be able to get something about it. When you start talking about there's a value C, the first thing you should start thinking about is, can I do mean value? Can I talk about continuous, differentiable, make a slope formula, and calculate it? All right. In question part C, it talks about h of x being ln of f of x, which is a little weird, but that's okay. But I think we can do it. If we learn some notation, this is an easy question. In fact, we know the notation. We just got to write it down. Okay? Can I erase this? Well, come on. All right, so it says they want you to take the derivative of this and plug 3 in. So let's write the notation out, not with u's, but with function notation. The derivative of h has to be equal to, don't you always put what's inside your ln on the bottom? Okay? And don't you put the derivative of that on top? Is everybody with me so far? Or you could say 1 over f of x and put the f prime of x beside it, and that would also be correct notation. Because you don't have to have them on top of each other. Now, we got all these values in this table. All we got to do is look them up. H prime of 3 is equal to f prime of 3 over f of 3. So go up there and look at your chart. Find 3. Tell me what the derivative at 3 is. 1/2. And what is the value of the function at 3? 7. Which means I'm going to flip and multiply. Everybody agree? So if I flip and multiply, what will I get? And you don't have to show the flip and multiply part, by the way. You just have to do it. But if you want to show it, you can. So 1/14. You got 2 points for setting it up and 1 for the 1/14. This is 3 points. Look how easy those 3 points are. Just because you know how to write derivative notation for log. Are you okay with that?
I understand that you use like ln work to do that
Mm-hmm.
derivative.
And once you do that, you come up here to your chart. You find 3. You pick off the value of the function and put it on the bottom, and the value of the derivative and put it on top and divide. Or if you had this as 1 over this times the derivative, it would have been 1/7 times 1/2 already. All right. So that's how these problems work. When they give you a chart like this, they assume that you're going to write the notation out so you know what to plug in off the chart. Same thing with this one right here. This looks hard, but actually it's really easy. It amazed me how easy this question was once I started looking at it. All right, so in this question on number D, letter D, it says from -2 to 3, evaluate this function. Well, when I evaluate that, doesn't that -2 and 3 go out here? All right. According to derivatives, isn't the derivative of the inside supposed to be sitting over here? Oh, wow, it is. So all we do is integrate the outside. What does f prime integrate to? F. It still has g inside of it, but you integrate the outside. The inside stays the same when you do chain rule, right? And don't we always throw away the du? Okay. So now all I've got to do is look up some values, and I'll be able to calculate this. Now it's composition, so it's a little different way of doing it, but it's easy. It's really, really easy. Now, I need to be able to bring this up here, so I'm going to move up here. All right. So first of all, we're doing f of g of 3, and when we get the answer to that, we're going to subtract f of g of 2. Is everybody with me so far? Excuse me, negative 2. Is everybody with me so far? Just notation. Now to do this, you've got to look up the answer to g, and that becomes the answer that goes in here. So what's g of 3? Everybody see that? G of 3 is 1. So we plug that in here, and we go look up g of negative 2. What is g of negative 2? Okay, everybody with me so far? You want to do both of those before you do the f part. Now we'll focus on the f line. What is f of 1? What is f of negative 1? And 8 minus 2 is negative 6. Now, let's talk about how they grade it. You get 1 point, you get 2 points for showing this and showing this. You get 1 point for the answer being negative 6. So you get 2, really, they probably break it down more than that, but they're saying this turns into this with the numbers plugged in is worth 2 points. And you want to show this step because I think that's part of that 2 points, and then the answer that you get at the end is the answer for 1 more point. It's worth 3 question points. And all you're doing is looking up numbers off of a chart. So it's composition, but it's easy composition stuff with a chart. That one's a really easy question. I hope y'all get one of those because I think those are great. Well, they don't put it on there every year, but they didn't have it last year. I don't think, so maybe we got a chance.
Yeah, exactly. Bad luck.
The bathroom room.
Okay. All right, the next thing we're going to look at, y'all, and I don't know what order they're in your packet, so if they're, okay, is it number 6? Okay, that's what I want to go to next. I didn't have my chart up here in the right order, but I do have that the way I was wanting it. All right. In number 6, it says, consider the curve given by the equation, which happens to be an implicit formula. Does everybody see that? This is implicit. X's and Y's are together. Someone's already done the derivative work for you. Now, that doesn't mean they will always do that for you, but you got an implicit button on your 89 that does implicit, so if you can't get it yourself, you could always use that button. On the non-calculator, you got to know how to do it by hand, so, you know, that's one of those things. Write the equation of the tangent line given this point. All right, what do I have to get a tangent line equation? Okay, I guess we better calculate our slope. So in part A, all we need to do is what? Plug them in. Yeah, we plug in this x and this y. So everybody calculate that up real quick. You mean like y2 minus y1 thing?
No, it's like that line just had to be higher than the
Oh, yes, let's talk about that. That's why I was looking for my answers to this one. I wanted to look and see what they wrote. Yes. In fact, they wrote even a little bit more, so let me show you a little bit more notation on that. They wrote x comma y is equal to negative 1, 1. So it's a little bit more involved than I even showed y'all before, because they want to know it's an xy point to relate to the dy and the dx, and then list the point. Then you show the calculation, like show the numbers plugged in, and then you can do it all in your head and write the final answer. This question is worth 2 points, 1 to get the slope and 1 to get the equation. So if you calculate this up correctly, that's just show a little bit of work, and they'll give you the credit. And I want to show y'all something else that I thought was really interesting. When you get the answer Yes, your answer here is M. They don't want you to write M equals, but that you need to know that's M. Because they want derivative notation instead of slope words. Miss Bennett was in here the other day, and she said what the M stands for slope on? I had never heard this. She said she saw it on a video. She says the B for the y-intercept stands for begins here, and the M in slope stands for move.
You know what? That's actually really easy to remember. I actually like that.
And it really makes sense, but I'd never heard any textbook tell what those two letters stood for. But it was some rap video that she heard and goes, and that may not be what the intention originally was for, but isn't that nice of a mnemonic for it?
Yeah.
All right, what are y'all getting for this number? 1/4. Now here, I want to tell y'all something. I found out something. They don't always have to have y equals mx plus b. The answer on this answer key shows this. Just move your number over.
Well, if I don't remember to do that.
Right. I don't think they'll count off, but the thing is all you got to do is remember that over there. Don't even distribute.
So if we were to do that on the AP exam, we wouldn't get it.
I don't know what they would do if you go further, but I'm just saying you don't have to. Save some time. This is like vertex form without the square on it for quadratics, because you can pull the number out, make it the opposite, and there's your up and down number on the end. So that's why they're leaving it in that format. You can still see your -1, 1 that way.
If you wrote your answer, your answer in both formats.
I don't think it would matter, but
Okay.
I'm just saying you can save time.
Well, yeah, because sometimes I know that I mean, if they want it broken up or not. So sometimes I just write both.
Yeah, there's nothing wrong with writing both. All right, so that's worth 2 points. So now part B, find the coordinates of all points on the curve of which the tangent line of the curve would be vertical. Well, when is the slope vertical? What does that mean? Huh? Bottom is 0. Yes, it is something about 0, but it's about the bottom is 0. Yeah, vertical has to be bottom. Horizontal has to be top. You might want to make yourself a note to remind yourself of that vertical means the bottom's equal to 0 and horizontal means the top's equal to 0, because vertical has no slope, right? And the only way to make this no slope is if the bottom is 0. So we just have to take this equation, set it equal to 0. Now, obviously, with this particular question, there's going to be some things that, are a little different, okay? So first of all, that's got an x and a y. How do I solve that? Well, one way you could solve it is just move the x over so that your variables are on different sides. Does that make sense so far? Now, this is the derivative formula. We've got it set up. We could plug that in over here for x, so we'd have all one letter and solve it, and then we'd know where it happened. Because this is the relationship in the derivative that makes the variables, this one's got to be tripled and squared to be equal to the x, okay? So because of that, I have to figure out what values in the original problem will cause that relationship to happen. Since I have 2 unknowns, I have to merge the original problem with the derivative equation. So y cubed minus 3y squared times y equals 2 will get me a formula that has the right relationship for x and y, but all y's. So first you did that. That's worth 1 point over there. Merging the formulas and solving the formula out is worth 1 point, and then you got to go back and find the other value in a minute. So isn't this going to be y cubed minus 3y cubed equals 2? That's right, makes it negative 2y cubed is 2. Divide, negative 1. What's the cube root of negative 1? Negative 1. Now, that's half of the answer they're asking for. They're asking for the coordinates of all points. Do I need a plus or minus on that? No, because that's a cube root. Then you plug it in over here. And that gives you that x is 3. So then you write a sentence with what the question's asking for with the answer to the question. So the question says, which tangent line to the curve at those points is vertical? So the tangent line to the curve is vertical at the point 3, -1. So first we solved the derivative equal to 0 on the bottom, got an equation that we could substitute in the original problem so we could all be one letter. This solving for x over here was worth 1 point. Solving this equation for y and getting that value to plug back into the derivative to find the x was worth another point. And then putting the coordinates into a sentence was worth your third point. Okay.
Where did you get the negative? You said the point.
I said 3, -1. Because this multiplies out to be 3. Right? And so that would make the point 3, -1. Okay.
I see what you guys.
And all I did was take the sentence that they gave me for the question and reword it into an answer. The tangent line to the curve is vertical at the point 3, -1. Now, the last question asks you to take the second derivative and evaluate it at -1, 1, which is the point they also ask you about in Part A. How do you take a second derivative? Well, you do the derivative of it. Okay? Now, because this is a second derivative of an implicit, it's going to be a little different than what you're used to. We always put dy or dx on it, but now we can't do that because it's a second derivative. We're going to have to be a little bit more notating. But it's the same idea. Isn't that a quotient rule up there? Okay. So the second derivative of y with respect to x is going to be equal to, don't you write down the denominator and take the derivative of the numerator. Everybody agree? Only after you get the formula set up. Yeah. So what is the derivative of y? 1. And the notation is 1 dy over dx. Because that was y. And anytime you take the derivative of y, it always ends up being dy over dx. Minus, right the top, what's the derivative of the bottom? Well, the bottom is 6y minus x. So it's going to turn to a 1, right? I don't have to put any on that. And the reason why is because I'm using dy over dx for y, so nobody else gets any letters on them. That's why you do that. It makes the math a whole lot easier. Then I put it over the denominator squared. Right? The denominator squared, I don't square it out, I just write it like that. Oh yeah, I left one off. Who else did I take a derivative of y to? I did another derivative of y. There. Yeah. I said it, but I didn't write it. Derivative of y. So only the derivative of y terms get dy over dx. The derivative of x terms don't get anything because we already got dx down there where it goes. And there's a reason for that. Okay? And here is the reason for that. In question number A, you did that point slope is 1/4, and everywhere you wrote this dy over dx, you plug in 1/4. If you split the dy and the dx up, you don't have that number you have to plug in. Does that make sense? Does that make sense to everybody on why we need those two letters to stay together and not be separated all over the place like we usually do? So when you're doing a second derivative of an implicit, you don't write dy on some and dx on others. You just write dy over dx on all the y derivatives, and dx derivatives don't get anything extra. Now, I'm going to stop with this one, but to get the second part of this question, because I'm going to run out of time if I don't. The implicit differentiation here and all of that work that you just did is worth 1 point. The second point in this question comes, well, too quick, from showing your notation of what you're plugging in all of these values, all your x's, all your y's, and your 1/4 for your dy over dx's, and evaluating it. Okay? Once you show Actually, this question's worth 4 points. Let me rephrase on that. You get 2 points for this differentiation, 1 point for substitution, and 1 point for the final answer. So it's worth 4 points. And it's not that complicated except for that little small difference, because we've never done an implicit much with second differentiations. We've just always did them with the first derivative and kept our dy's and our dx's separate. But this is how you can do it and keep them together. So I'm going to stop there because I know y'all can plug numbers in. But everybody understands that the dy over dx is 1/4 because we calculated that in part A. I like that they used that same point because that saved us some time.
Our rig questions, they're going to be calculator active.
Not all of them. No, we need to talk about that. All right, let's look at the next one. In number 6, on the next one, they gave you a derivative formula, and they're asking you some information about this. And this one is a really short question, but it has some great parts that might be on the multiple choice section. I think I saw one of them kind of like this A question in the A section of multiple choice. And then part B is talking about particular solutions, which I think was 5-7 that I skipped, but it's not hard. All right, so first of all, they gave me a derivative. Everybody sees that, right? So if I want to know what f of x is, I might need to integrate that. Would everybody agree with that? I'm pretty sure this is on the open-ended part of the test that uses a calculator, because they're asking me to approximate a decimal. But that's one thing. Second thing is, it says write the equation of the tangent line of f at point 1, 0. Use that to approximate 1.2. Because what the problem is it might be on the non-calculator part of the test. I can't remember. I'll have to go back and look this one up to be sure. But that is possible that you can get an approximate answer and not have to worry about a decimal answer. So let me show you that. First of all, how you get a tangent line equation? You got to have a slope. Okay. Do I have a derivative to calculate my slope? Yes. So dy over dx has to have what next to it because of our fancy notation we're doing now? 1, 0, because we're using that point to help us figure out what this 0.2 difference is. So we plug that in, e to the 0, 3 times 1 squared minus 6 times 1, and come up with the final answer, and that'll be worth 1 point. Right? So it's just 3 minus 6, isn't it? Because 1 times anything's not going to change it. So it's -3. Everybody agree? All right. And then in the next part of this same question, we have to come up with the equation of the tangent line, because that's what the first sentence asks us to do. So that's y, what? Minus 0 equals -3, x minus 1. Everybody agree with that? So we could just drop the 0, not multiply it out, no reason to. Everybody with me? Now, let me explain to you what we're just finding here. Pretend for just a moment that this graph has been graphed, and we know over here, that's a belly graph. Let me try that again. That is not what I wanted. And over here at 1, we're looking at this tangent line. Okay? It's negative, right? Slope's negative. The problem is that that's the 1.2. Okay? That I'm looking at the tangent line in the second part of this question. But over here at 1, it would be really close. It wouldn't be that much different. Does that make sense? So what they're saying is that if you find the slope of the tangent line at that point, we can approximate the original function by approximating the tangent line of this line is almost identical to the tangent line of that one. Does that make sense? So what they do, this is called tangent approximation. And depending on what they give you originally, sometimes you might have to do the slope formula, y2 minus y1 or x2 minus x1, if they'd given you values of derivatives or slope numbers to work with. But since they gave me an equation, I was able to get the tangent line equation here. And what I do is, notation-wise, f 1.2 is going to be equal to plugging 1.2 in this formula, because the tangent line y value should be almost identical to the f of x value of 1.2, because those two tangent lines are almost at the same slant. Do you see that? That the tangent line of 1.2 is almost the same as that solid blue line. So since they almost have the same slant, we can approximate it by plugging it in the derivative. And so whatever that comes out to be is the answer. And I think that would come out to be 0.2 times negative 3 is negative 0.6. Would everybody agree with that? So first, you get a point for calculating up the derivative and a point for getting the tangent line equation. I think all of you could do that. Don't you feel like you're confident that you could do that?
So how many points do we have so far? 3?
There's 3 on this whole question. 1 for that, 1 for this, and 1 for that.
I thought it was supposed to be 5.
Well, this is just part A.
Oh, okay. Okay, that's what I'm just.
Yeah, just part A. It's 3. There's 6 points in part B. All right. Now, we can do part B. You are capable of doing part B. You have been doing part B. Actually, I think we've done every bit of this part B. I don't think there's anything here we haven't done in part B, except maybe call it particular solutions. Can you find C? Yeah. You can do it all. So, I'm going to give you some instruction. I'm going to let you try while I go and look up some more stuff, and I'm going to try to make the error come on. I want you to integrate this. I want you to put the dx over here and the things with y over here and integrate both sides and get it down to it's integrated, and plug in the 0.10, and I want you to see if you can figure out what C is. Okay? We've done that 100 times. And I'm going to pause the video while y'all do that. All right, so we're talking about integrating a problem, setting up the integration by switching dx and e to the y. Actually integrating it is worth 3 points. Getting the constant of the problem is worth 1 point. So solving the problem out to C is very important, because that's worth 4 points already. Now, we've got to go back and plug this in for C and get this into a y equal to format. Okay? So when we do that, when we get it into a y equal to format, right now our formula is not y equal to, it's an e thingy, right?
Yeah, sadly.
So first of all, we could take the negative through the whole entire problem, and that would get rid of it. Everybody agree with that? That might be a good idea. Second of all, we could have not done that if we didn't want to. I mean, there are other ways to write the answers. There's more than one way. Yes, we can LN both sides. Now, when we LN both sides, do we need any absolute value bars? Possibly. This will always be positive, and 3 times that's going to make it bigger than that, more than likely. This will always be positive or negative, and with that, it's going to make it the opposite. So, yeah, we might want to, I didn't put one in there, but might want some absolute value bars. E and Ln cancel out. Everybody agree with that? So if I have Ln of these absolute value bars, then my problem is going to be y equals negative Ln of this problem. Now, solving that for y all the way to that point, okay? Get you all the points. It's worth 6. Right, we've done this a lot. This is not something we haven't done. You just got to take the time to show every little step.
There's little opportunities for error.
There is. All right. So that got us through 2 kind of derivative problems with integration type questions. We also got to look at one with a table. Now, The rest of what I have on there, I think is slope fill, isn't it? There's one more?
Yeah, there's only one after this. This is like one.
Yeah, both of those are slope fill, I think. Yeah, both of those are slope fill. So I'm going to save that. I'm going to go to the multiple choice A section now and talk about that, and we'll talk about slope fills on Monday. But what I would like y'all to do this weekend is to take some time to go out to Khan Academy and watch the lessons on slope fills, if you could, to get a little background on slope fills and watch them work some questions on how to make a slope fill, how to figure out how to put the curve in a slope fill. And on Khan Academy, they have some really good lessons on slope fills. So I feel like if y'all watch some of that, then when I start talking about it, it'll just help reinforce it instead of just hearing it once. Does that make sense? Okay. Now, everybody got their A section?
Miss Johnson, are you gonna be here early on Monday morning?
Yes, ma'am. Do you want?
I'll be here at 7.
Okay.
I should be able to.
Okay. All right. I think we need to go back to number 4 because we skipped number 4 in the A section. Because some of you said you really wanted to talk about trapezoidal sum. So that's where I thought we would start today. And I have maybe 2 I don't know how to do. Because my brain just wasn't working last night when I was trying to work on this.
Well, that's bad. Miss Johnson doesn't know how to do it.
Well, after I did quite a few of them, I ended up, well, I ran out of time, so I didn't have time to really think them through. Hold on a minute, I got to figure out my attendance. I don't know if anybody was out in there. I'm just going to say nobody was for right this minute and do my attendance. I'll go back and fix it later if it's wrong. I can't remember who was out in third period. I know Logan was. I know Casey was. I don't think I had anybody else out. All right. I got this in here somewhere, y'all. Hold on. I just got to find it. I don't think this is it. Why don't you roll? I know this is it. What is wrong with this thing?
Right there was. It popped up.
Okay, alright, I'll go back again. There we go. Now it won't roll. Why is it being so slow, y'all? Am I doing something crazy?
Probably a really big file.
Okay, that's probably it. Come on. 4. Yay! Finally. All right, so it talks about trapezoidal sum, and Kinsey was telling me that she was having a little trouble remembering that.
Yeah, that's fine.
All right, so let me talk about that. Number 1, trapezoid formula has to do with 1/2 times the 2 bases added together times the height. Okay? That's normal trapezoids. So it's 1/2 times the whole problem, because every one of these is going to have a half on it. Does that make sense so far? In trapezoidal, it's the difference from here to here on how wide or how tall your trapezoid is. So from there to there is 0.5. You've got 2 bases. Your y values are the bases. This is B1 and B2. The difference of these 2 is your height. If you think about the formula, 1/2 times h times B1 plus B2, that's trapezoid.
Oh, that's a...
So 20 plus 60 times a half. Next one, how far is it from here to here? Well, it's 1.5. What are my 2 bases? 60 and 40. Because the bases on these trapezoids are drawn in this direction. So the bases are the 2 sides, your y values. So then, how far is it from here to here is 1, 40 plus 30. And you add all that together and multiply it by 1/2 and you're done. Now, that's all I'm going to talk about, y'all, because I know y'all can add and multiply and all that. But does that help you get enough to go back and study trapezoid and be able to do one?
Yeah.
Okay.
I actually had remembered that.
Good. Well,
Remember the formulas, I probably won't need much of.
okay.
Different or the subtraction.
I think the next one is number 9, y'all. All right. So in number 9, and I don't know why I'm sitting here trying to write on these because it's probably going to make my machine do something funky, but oh well. In number 9, this is a graph of a function, and they're asking us to evaluate which of these sections would have what size answer. Now remember, integrating is all about what? Area. Okay. So they're asking us to tell which one has the smallest area. So let's talk about each one. Wouldn't you agree from 2 to 0 to 2 is a positive area? Wouldn't you agree that from 2 to 3 is a negative area because it's below the line? Then the difference of that would be smaller than the first one, wouldn't it? Okay. Everybody with me so far? So when you start looking at these answers, who would have the smallest answer? 0 to 2, 2 to 3, or 0 to 3? 2 to 3. So that rules out these two. Now, who would have the next size answer? 0 to 2 or 0 to 3? 0 to 3 would be next because 0 to 3 is the difference of these two. Right, the area of the whole thing, which is the big part that's positive, minus the bottom. And that's why the answer is C, because 0 D, because 0 to 3 is the 0 to 2 plus the 2 to 3, and this one's negative and this one's positive, and that subtracts. It makes it smaller. Does that make sense? Okay. Then we're moving on. All right, so the next question I think that we had, and I'll just keep turning through my pages here. I didn't do 12, that's correct. I'm pretty sure I didn't.
I was going to say, I got it right, so I might just not have written anything on it.
No, I didn't do it. It says the number of gallons of water in the tank is W sub T. What is the rate in gallons per minute that the amount of water in the tank changes at T equals 3? Now, first of all, always look at your units. It says, what is the rate? The moment you see that has units on it, and this over here, W stands for gallons, what is that telling you need to do? Differentiate or integrate? That's right. So that's why you differentiate it and get negative 2T, plug in the 3, and get negative 6. Now I'm going to skip number 13 for now, because that's a slope field, and I thought we'd talk about that on Monday, because that is the one of the questions I don't know how to do, and I'm going to ask Joseph, because he comes home tomorrow. I haven't taught slope fields enough to be able to pick that out very well. All right. Population of yeast is Y sub T. They gave me a derivative formula for it. They asked me to take T equals 0 is 120, increasing rate at 24 grams per day. Which of the following would be the expression? So first of all, let's use some common sense about this question. Where does the beginning amount in an E problem end up? In the front. Okay. So since this is your start value, we know these two can't be right because it's got to be in the front. Is everybody with me so far? Is that a problem? Everybody with me? Everybody okay with that? Now, we got to figure out this power issue here. So let me talk about that. This derivative formula has to be used to find K. Okay? So to use that derivative formula, we know that dy over dt is equal to 24 per day. This is dy over dt because that's my rate. And that is the rate it is. I forgot where I was going with that. That's right. This is a y, and this 120 is y. Because when t is 0, y is 120. Everybody with me there? Okay. So I've got to calculate my k from plugging those two values in the derivative to find the rate. So that's 24 divided by 120. That reduces by 6 to make 4. That reduces by 6 to make 20. So that'll make 1/5. Now which one is it? There you go. So sometimes they're going to give you a rate that you can plug in the derivative and find a value for k. Sometimes you might have to integrate and plug numbers in. If that 24 hadn't been a rate, I'd have had to integrate first and plug my numbers in. We didn't do 15, that's correct. So we're going to look at 15. In 15, you have to interpret what these graphs mean so that you can understand what these notations down here are. So let's go through and interpret. So out of the graph of f, the limit at 1 is 0. Does everybody understand that? Well, then this one's true. The limit at 2 of g of x, it's broke. What does that tell me? Well, then that one's true. The limit at 1 of f of x, g of x plus 1 does not exist. So we got to check that. Or is the limit at 1 of f of x plus 1, g of x doesn't exist. So let's go through and calculate it and see how that works. If you plug 1 in the f function, what is the y value? If you do f of 1, what is the y value? Nope. You're right, 2. Yeah, it's 2. It's not supposed to be, though, is it? All right. G plus 1, if you add 1 and 1, you get 2. It's broke over there. So this function's broken at that value. So this one doesn't exist because it's broke. It has 2 different answers. That's a problem, right? So that sounds like that'll be the answer. Let's double check and make sure. If you plug 1 in this function, 1 plus 1 is 2, and at 2, it's negative 1. Everybody agree? And if you plug 1 in this function, the answer is 1. That's workable. So it has to be this one. I don't know if that's true, though.
She's gonna lie. It has to be a lie.
That has to be the last one, is what I was going for.
But that one works. But you,
It's asking which one is false.
so it has to be this one. And here's why. Here's why. You were supposed to use this value to calculate it, first of all. Because that limit of that piece is not this point, number 1. And number 2, that you can't pick the value of that one and say it doesn't exist because, and I know it looks like it doesn't, but x plus 1, I plug in 1 here, I get 1 because that's the limit at that. I plug in 1 plus 1 is 2, but it's colored in at 1. It's not colored in at the other one. They don't meet. I know that's the correct answer, y'all.
I don't know why I just circled it.
Because this is 0. And this one over here is 1. And 1 times 0 is a number.
Okay.
You see, this has a limit at that spot. Okay? This has a value at that spot colored in. And even if I use the value up here, saying that one was colored in, even if I use that one, it has an answer. This times this does exist. Does that make sense? Because you have to do all of this inside of here before you do the limit. Don't do the limit in pieces. That's what we were doing wrong. So even if I say this is colored in at 2, and this is colored in at 1, and multiply those together and get 3, that number exists because I got a math answer. Does everybody understand? Then if I do the limit at 1, it's not 3. But, I mean, in some respects, it seems like it wouldn't be 3, but that's what the values there give you. And that means that it does exist. So you have to use the colored in dots to evaluate the function and then say the limit at 1 is 3 doesn't match that, so that's why it's false. So be careful. Don't do the limit of each one. Do the answer to the problem first, because that's what makes it so easy to miss, because I did that before I realized it earlier when I was going through them the first time. All right, I think we did those two, didn't we? We did not? Okay, we'll talk about 17 then. In question number 17, you are giving a particle's moving along the x-axis, which means it's moving at some kind of velocity. and they gave you the x, and this is what is so important. This is position. X is how far it's moved, just like s of x, t is position. We want to know the velocity, so to get velocity, you always have to do what? The derivative. So you go through the process of doing the derivative of a product rule. So we write down the first, the derivative of sine is cosine, plus write down the sine, and do the derivative of your problem here, which all that does is put a negative on that, right? Everybody agree? Negative 12 e to the negative t, because the derivative of the power is negative. That's all it does when you do e's. You take the derivative of the power and put it in front and you're done. Now sometimes it's a lot more involved in that, but that one happened to be an easy one. Now it asks me to find out when is the first time it'll be 0. So I might want to simplify this a little bit. That looks a little complicated. Can we take a 12 out? Can we take an e to the negative t out? Okay. It doesn't take the negative out though, does it? So that puts it in front of the sign. Will this ever be 0? Will e to the negative t ever be 0? No. An exponential will never be 0 unless there's some up and down motion, and there's no up and down motion in that. So this part's going to be equal to 0. Now, when this is equal to 0, let's talk about this cosine and sine. For them to be equal to 0, wouldn't they have to be equal to each other? What fraction on the unit circle has two numbers that are equal to each other? Okay, so that's pi over 4. And that's what the answer is.
Make this math look simple, but then as soon as we start this test, I'm gonna look at it, it's gonna look like I'm taking a Japanese test.
I don't think so. Alright, now have we done 21?
We haven't done
We haven't done 19? Okay. I guess yes, you're right. We haven't done 19. This is one I had to look up something for y'all. And it was like one of the open-endeds we looked at today. Alright. It's an approximate, so let's talk about that again. Alright, let me show you the formula for approximating, because sometimes approximating's the problem out is a little different from that open-ended question because of what numbers you have. The formula for approximating a function is the function evaluated at the value they give you, the derivative at the value they give you, times x minus a, where x stands for what you'd like to do, but a is the number they told you to do. Okay? So in this problem, I'd like to do 1.5. That's x. But I'm going to have to use pi over 2 because that's what I know. See, I can't use a calculator on this one. I'm pretty sure this is non-calculated part of the test. So that's why they want you to approximate it with this. That's going to be a. So first I plug in pi over 2 in the function and evaluate f of a. So cosine at pi over 2 is 0. 2 times 0 plus 1 is 1. Then I evaluate the derivative. The derivative of this function is going to be negative 2 sine of x. Everybody agree? So if I put pi over 2 in for that, isn't sine of pi over 2 1? And times negative 2 is negative 2. Then I have to know what pi divided by 2 is. Well, what's 3.14 divided by 2? Approximately 1.57. And minus 1.5, 1 minus 2 times 0.07. 0.07 times 2 is 0.14. 0.14 from 1. Okay, then I got to calculate these to see which one. So what is 3 point... I might have done that math wrong, y'all. Okay, maybe not. 1.34 minus 2. How much is that? I lost a negative somewhere. Because I subtracted them backwards. It's 1.5 minus 1.57. And how I know that is I wrote X there, but I didn't write it down here. So that's negative. So that's positive. That comes out 1.14. That comes out 1.14. So you just got to turn each one of your answers into a decimal if it don't match the whole numbers. And that's all approximate. I mean, I don't know the exact answer to this divided by 2. I know it's about 1.57 if you divide just into that much of it. And I know that I'm supposed to do X minus A. So that gives me that number. All right. Number 21. I think we didn't do that one, right? We did 21? Okay. Did we do 23? No. We have not. Wait a minute. I skipped way over. We didn't do 22. All right, let's do 22. Because we're going to run out of time. And I might give you a hint on 22 and have you go home and try that one. Or we just talk about it on Monday. I went to 22. I thought I was going to, no, that's what I'm supposed to. Okay. All right, it says y of 0 is e. So that's a value to plug in. I have a derivative formula over here that they're probably wanting me to integrate since all of these look like they've been integrated. So dy is equal to 2y on the bottom, 1 over 2x plus dx on the end because they switched, right? Everybody agree? So I take the half out and integrate 1 over y dy. What does 1 over y dy come out to be? ln, okay. ln of y. Over here, what's the derivative of 2x? Well, I don't have a 2, so I'm going to put a half in front. So that's going to be 1/2 ln of 2x plus 1. Probably need absolute value bars on that, I don't know. Plus c. I better be careful. Too much of that clicking stuff in my writing's going to go away. All right. Now, can I multiply the whole problem by 2 and get rid of the half? Or should I find my c first in case it affects that? Okay, so 0 is e. So that means 1/2 ln of e is equal to 1/2 ln of, let me change colors because I'm getting ready to run into that, 2 times 0 plus 1 plus c. ln and e cancel out, so that's a half. 2 times 0 plus 1 is 1. What's ln of 1? 0. So 1/2. Everybody agree with that? Did I make a math error? I think that's right. We do just what we did on that earlier problem, right? We're solving for C. Now, let's go back and let's think this through real quick. Now if I put that half over here, but ln of 1 is 0. Yeah, ln of 1 is 0. So this come out a half. Now they all have a half. If I double the whole problem, all those fractions go away. Wouldn't that be a great thing? Okay. Now if I do that, this will drop off, and this will become a 1 if I double the whole problem. Now if I do e to both sides, won't that make it y equals? Everybody agree? If I do e to both sides, won't that make it y equals? Okay. So if I do e to this side and e to this side, I'm going to have to go up here, y'all. I'm running out of room. That's going to make it y equals. This is going to be e to this whole thing. E to the ln 2x plus 1 on the end. Everybody with me there? Now, normally, what did that c end up doing in all of our problems? It always came out in front of the e. Okay. But it's 1, so is that going to make any difference? Okay, so if this represents C, and I bring it out here, that's not going to do anything. That will get that C off so I can cancel and do some things maybe here, or it will do some things to the question in terms of setting it up. Now, if I don't do that, I might not see where it's going. So that might be important. Well, I'm having a terrible time today with my throat. Trying to figure out where my LM went. I don't even remember which answer was right on this one. This is the correct answer to the question. Somebody help me figure out where they went.
They brought they left.
They brought the two out of the absolute, no.
It does look that way, doesn't it?
But
I think this problem has a typo in it. Because I think this X is supposed to be up there. And let me tell you why. E to the 2X, E to the 1. E to the X, E to the 1.
an X would make more sense. Yeah, it would.
See, I think what's happening is these two don't cancel out. Like you, on this side, like you think they would. There's some stretching capacity, I don't know, some kind of power rules they've done here.
But where does the LN go if it doesn't use? Yeah.
I don't know. You want to come back to this one on Monday? I'll try to do some more work. I did this much work, but maybe I didn't write all my steps down because I don't see where it went.
Ask Joseph what's up with this. Yeah.
Yeah, I'll ask Joseph. He knows. All right. I also have to ask Joseph about number 26 that we were working the other day with that E and the LN thing there too. It's probably some simple little ELN thing that I've just forgotten about. All right, we'll come back and we'll start there. Now, I'm going to pause the video.